we just started basics, very basic of it. We will really
Okay.
start.
So are we starting substitution?
Yes.
Okay, so whenever everyone will join, we'll see, but we should start the class now. So Nasir, we are also on substitution method only. We will be actually doing substitution today.
Okay, sir.
Okay, so there are three methods in which we can approach integration. First is by substitution. Then second is partial fraction, using partial fraction. And third is, actually, I think second is in the NCRT, second is this, using by parts. But it doesn't matter which one is second and which one is third. You have to learn all of them. So there are three methods basically by which we can approach this chapter, and they are mainly substitution, partial fraction, and by parts, right? So whenever I'll face any problem, I'll have to categorize that problem into one of the method. First of all, that will be my first approach. That will be my first step. And then I'll be deciding how to do this by that particular approach. So the most important one here is substitution. Substitution is the best approach. Substitution is the most used approach, I would say, in all of them. And how do we substitute, or how do we find out integration using substitution? We'll learn that. So let's start with one example only. Suppose we have to integrate this function. So this is written 2x into e to the power x square, right? 2x into e to the power x square. Now we don't know the integration of 2x. Sorry, we know the integration of 2x, but we don't know the integration of e to the power x square. We know the integration of e to the power x. Integration of e to the power x is e to the power x, right? Plus. But we don't know the integration of e to the power x square. In fact, this will be a tough integration. I mean, you'll study it in your BTech if you do choose for engineering. So you will learn this, how to integrate e to the power x square in engineering. So this is a very tough integration, by the way. So e to the power x square, but we don't know yet, right? And 2x, I know I can integrate 2x, but when 2x is multiplied by e to the power x square, I don't know the integration. I don't have any direct formula related to this, right? So what I can do is, in substitution, you choose one function such that its differentiation is also present in the same mathematical expression. So let's say I choose x square for a moment. Let this x square is some other variable t. Then what you can do is you can differentiate this x square, which would be 2x with respect to x, and you can differentiate this t as well with respect to x. So you are differentiating this whole this whole expression on both sides with respect to x. So when you differentiate x square with respect to x, it would become 2x. When you differentiate t with respect to x, it would become dt by dx. Now multiply dx in the left hand side. So take dx on left hand side. This will become 2x dx is equals to dt. Right? Now, why we have done this, and how would I know that we have to do this? There are two questions. First of all, why we have done this? We have done this so that this 2x dx can become dt. Now, see this. What does this integration become? We have 2x dx, which will become dt according to our substitution. We have e to the power x square, which would become e to the power t. So now the integration, which seems impossible for a moment ago, is very much within our range because we know the formula for e to the power t. E to the power t dt, integration of e to the power t dt is e to the power t plus c. E to the power t is now substitute back. T is x square, so this would become e to the power x square plus c. Now there were two questions. First, why we have done this? We have done this so that we can integrate our original expression, which wasn't possible because we don't know the formula for 2x into e to the power x square. But this is possible now because we have substituted this x square as t, and from the help of this substitution, we get the value of 2x dx, which would become dt. So the formula is e to the power t dt. seems highly possible. And how, now the second question is, how would we know that what to substitute? Now the substitution depends whether you have the differentiation of that function in the same expression or not. So here I substituted x square, right? Now when I substitute x square, I knew that differentiation of x square would be 2x, so that my 2x can be replaced, right, with dt. So every time I'm going to substitute any expression, I will have to make sure that the differentiation of that function is also present in the expression. For example, let's take some more examples. Integration of 2x sine of x square plus 1. Now, first of all, you know the integration of 2x, but you don't know the integration of sine of x square plus 1. But first, give me this answer. Diana, can you answer this? What is the integration of sine of x plus 1 dx?
Minus cos of x plus 1.
Right, plus. But do we know the integration of this sine of x square plus 1?
Well, in that
But
expression,
this is not a linear. This is not a linear expression, first of all, right?
yeah.
So this is a quadratic transformation. We have converted x as x square plus 1. This is a quadratic transformation, and this is not easy to calculate. It's not easy to solve. So it's a tough question. If you ask me what is the integration of sine of x square plus 1, we have to use certain other methods which are not in your series. So we don't know sine of integration of sine of x plus 1. So we are facing two problems here. Now listen to me very carefully. The first one is we don't know the integration of sine of x square plus 1. And the second problem is there are two functions. First is 2x and second is sine of x square plus 1, which are in multiplication. We also don't know when there are two functions in multiplication, how to integrate it when there are two functions in multiplication. So to remove these both problems, we have to make sure that we substitute something, and substitute such as the differentiation of that function is also present in the same function. So can you find out the substitution for me? What is the expression that needs to be substituted in?
T is equal to x squared plus 1.
X square plus 1. Yes. If we substitute x square plus 1 as t, then the differentiation of this function, which is 2x, is also present in the same function. So x square plus 1, differentiating both sides with respect to x, this would become 2x plus 1 is 0. Differentiation of 1 is 0. And this would become dt by dx. Hence, dt is equals to 2x dx. So this 2x dx would become dt. This sign is as it is, x square plus 1 is t, then dt. 2x dx is dt. So this is nothing but sine t dt. Now it is very much possible. We can say that the answer is minus cos t plus c, which would be minus of cos t is nothing but x square plus 1 plus. So in substitution, we have to find out a function whose differentiation is also present in the expression, and we have to use both of them. We will substitute an expression as t or y or whatever you want to have. And then we will differentiate both sides. And using substitution and its differentiation, we will replace our original function. We will transform the original function into some function which will be integrable. of which we know the integration, how to integrate. Okay, can we proceed? So I'll have to write the general formula. How does this substitution work? You can note down these two examples if you haven't. Can we proceed? Okay. You can just raise your hand if you haven't written yet. But if you won't raise your hand, if you want to raise your hand, so I'd be assuming that you have already written. So how does substitution work is, if you find anything like this, if there is a function g dash x, which means differentiation of gx, and there is a function f of gx, that is, there is a composition of function given, there is a function gx given somewhere in the formula, and whose differentiation is also present. So what we do is, to solve this type of function, use substitution. We will substitute this gx as something t. Then g dash x into dx would be dt. This would be dt by dx. I have already multiplied dx in the left hand side. These two things are important. Now, using them, you can convert this integration as g dash x dx, which is dt. Then f of gx, which would become f of t. So ft dt, and this function should be integrated. Sometimes it may not be integrable. We have to apply substitution maybe 2 times. That can also happen. But most of the times it will work. Let's solve some questions. We'll get a fair idea like how to solve them. First, we'll start with some basic integration, tan x and cos x, tan x and cot x. They are also done using substitution. Tan x dx. I want to integrate tan x dx. Let's say its answer is I. So I need to find I. Am I audible?
So your voice is a bit breaking.
Am I? Okay, just a minute. I know my network connection is good. Am I audible, Jan?
Yes, sir.
Okay. Yeah. So I was saying that we have to integrate tan x. Okay. So integration of tan x, cot x, sec x, and cosec x is also done using substitution only. To integrate tan x, what we can do is we can write this as sine x by cos x. Now see, the differentiation of sine x is cos x, And the differentiation of cos x is minus sin x. Minus sin x is also good. No worries. But let's try out two things. So I am not sure whether I should substitute sin x or cos x. Why? Because differentiation of sin x is cos x, which is present in the function. Differentiation of cos is minus sin x, but that is also present in the function, right? So I'm not sure whether to substitute sin or cos. What I will do is I'll substitute both of them. But in the first case, because I'm actually trying the first question only. So I'll substitute both of them, and then you will see for yourself what can happen. How do we substitute? So let's say in first case, sin x is equals to t, and in second case, let cos x is equals to t. I'll solve this part first. Let sin x is equals to t. Then if we integrate both sides, this will become cos x t. T will become dt by dx. I'm taking dx in the left hand side already. So this will become cos x dx into dt. There are two things. Let's try to substitute them. If I put this, both of them in the formula, in the integration, this will become I is equals to sin x is t, right, upon cos x. So see, the problem is here we don't have cos x into dx. So we don't have cos x into dx as dt. If here cos, it would be very simple to integrate. It would be the best thing for this integration. But we don't have this dx by cos x. We have cos x into dx, which cannot be substituted because it won't lead us to any answer. But let's say I substitute cos x as dt by dx. Okay. So what would it become then? Cos x would be dt by dx into dx. If I try to solve this, this would become t by dt into dx whole square, which is not a very sensible, expression. I don't know the integration of this. Nobody knows the integration of dx whole square by dt. No. And one more thing is we can't have two variables in the same expression, like t and x. If we are substituting, it means that everything has to be in t now. But if we not substitute, we are not able to substitute dx. So we cannot, and third is we cannot have these expression derivatives dt, dx in new denominator. So there are three problems related to this. We cannot approach by this. This is a wrong approach. What I wanted to tell you is that you have to find yourself what is the correct substitution. There will be questions, there will be a lot of questions where you won't be able to decide what should be the correct substitution. So always think it like this, that we have to, first of all, there are some rules. First rule is that whatever function you are substituting, there should be a derivative of that function present in the expression. If there is no derivative of that function present, then substitution is futile. Substitution is useless. Right? So the first thing is, whatever function you are substituting, the differentiation of that function should be present in the function. Now the second rule is, if you substitute anything, you should be able to move this dx. And in place of dx, you have to use d or whatever you are using. If you are using y, then dy. If you are using y, then dy. If you are using anything else, whatever variable you are using, we have to take d of that variable. You cannot have like dx and dt in the same place, or t with dx or x with dt. No, you will have to substitute the whole variable in that case. So let's approach this question from the second strategy, that put cos x as t. So if you put cos x as t, then we have minus sine x dx. The integration, sorry, the differentiation of cos x is minus sine x. So minus sine x dx as dt. Now see, we have sine x into dx. So that is a good substitution. That is how we should approach this problem. So what will it become is, this is t, sine x dx would be minus dt. Hence, I is equals to tan x dx becomes minus dt by t. You can take minus outside of the integration, and this will become minus of log t plus, which is nothing but minus of log t sine x plus c. So p is cos x, minus of log cos x plus c. You can apply the properties of logarithm to take this minus inside, which would become the power of cos x to the power minus 1 plus c. Cos x to the power minus 1 is nothing but 1 upon cos x, which is sec x. The log of sec x plus c. We apply more because input of log is positive all the time. You cannot take a negative log. Like log of minus 4 does not exist. Log of minus 10 does not exist. Did you understand this? The integration of tan x. You can ask any question if you have any problem. Liana, did you understand this?
Yes, sir.
So could you explain again?
Yeah. So what we were trying to do is, we were trying to find the right choice of substitution. Here we have two options. As soon as I see the question, I think I thought like this, that I have the differentiation of sine x present in the function, because differentiation of sine x is cos x, which is already there in the function, and differentiation of cos x is minus sine x, which is also present in the same function. So I faced a dilemma that whether to choose sine x as the whether to substitute sine x or whether to substitute cos x. So what did I do is, I tried both of them. First, I took sine x as t, and then I took cos x as t, and I solved both of them separately. So when I take sine x as t and then differentiate it, this become cos x into dx as dt. But unfortunately, in the question, I do not have cos x into dx. I have dx upon cos x, which suggests that this wasn't the good substitution. This was the right substitution, because we are not able to remove dx. If I put cos x as dt by dx, if I take dx on the right hand side, let's say I want to solve this question from this method only, but obviously this is not possible, but I want to check this. So I put cos x as dt by dx in the next step, and I substituted cos x as dt by dx. What did this become? This become t into dx whole square, because this dx would come in the numerator. So t into dx whole square upon dt. But I am not able to remove this dx until there are two variables in a integration. You will not be able to solve that integration. So the purpose of integration is to remove this dx, as well as to have this dt in the numerator. When I tried to solve this, I found out that this wasn't the correct substitution. So I tried second approach. I took cos x as t. As soon as I took cos x as t, what did it become is minus of sine x dx is equals to dt. If I differentiate this function both sides, so this become minus sine x into dx as dt. And here I have sine x into dx minus dt. So now this fulfills my purpose because I have already removed dx. I have dt in the numerator. There were two things. I had to remove dx and I had to take dt into the numerator, which both happen if I took cos x as t, if I substituted cos x. So sometimes you will be very confused that what is the right substitution. So remember two things. First, the differentiation of that function should be present in the expression. And second, you also have to remove dx. So choose the function such as the differentiation part removes dx. Just like it happened here. See, we got sine x into dx. In the first part, we got cos x into dx, but we didn't have cos x into dx. We had dx by cos x. If we would have here dx by cos x, then it would be a correct substitution. But in this case, no. Dana, did you understand this?
Yeah, so could you explain from a minus log cos x plus c?
This become minus dt by t minus, I have taken out minus from the integration side. This become minus of log t. Okay, dt by t is log t. And then I substituted back t. T was cos x. So this become minus of log cos x. Now I just applied the rules of logarithm here. So what does logarithm say is, can I remove this part? First, you note down this whole Liana and Nasser. Let's note this down. Then we'll start. Are you guys done? Can I remove this? Okay. You just have to raise your hand, Nasser. If you are not done, then you can raise your hand. If you are done, then you have to say nothing. Okay, so this is the property of log, Liana. Let's say I have this log x to the base a, and I have some powers. So what does log x to the base a means is, this means that x is the input of this log and a is the base of this log. So a is the base and x is the input, right? So, and how do we solve log? Log 8 base 2 means we want to calculate the power of 2 so that it becomes 8. The power of 2, that power of 2 is the answer of this log, which will make this 2 as 8. So 2 to the power 3 is 8. So hence the answer is 3. So logarithm gives you powers. What powers? Powers of base so that it becomes input. So can you answer me this? Log of 16 to the power, sorry, log 16 base 2?
4.
4. Okay. Now there are some rules. I'll tell you the one which I used in the previous question. So this is log, if you have x to the power n and a to the power n. So this is the power of input and this is the power of base. So what you can do is you can take them out of the log. How? The power of input will be in denominator and the power of base will be in, sorry, the power of input is in numerator and the power of base is in denominator. So you can take them out m by n and write this as log of x to the base. Similarly, you can reverse back to. So if you have something written outside of the log, you can take them into the log as powers. If there is something in numerator, you can take that into the power of input. If something is in denominator, you can take that into the power of base. Or you can also take this. You can also consider this m by n as a number and take that x to the power m by n to the base. So what did I do is, this was log t, outside was minus, so I did this. I took it as -1 into log t, and then I take -1 inside log, which would become log of t to the power -1, which is nothing but log of 1 by t. Is it okay now?
Yes, sir.
Have you done logarithmic differentiation? Oh, in that case, you don't know about these rules of logarithm, but either if you would have done logarithmic differentiation, there were all the formulae written. This was one of them. Okay, so let's calculate integration of cot x dx. So for integration of cot x dx, we can write this as cos x by sin x into dx. What should we substitute here? Cos x or sin x? As you can see, we have differentiation of cos x also and differentiation of sin x also present in the function. Differentiation of cos x is sin x, which is also present in the function, and differentiation of sin x is cos x. Both are present in the function. But what should be the right substitution? I want to ask this.
Sin x.
Remember, sin x. Why sin x, Nasir? No, I mean, the answer is correct, but I just want to know your theory. Like, did you get the algorithm? So why did we choose to substitute sin?
Because sin x is the integral of minus cos x. So 1 by t is equal to t minus 1. So
You can also see that we can substitute dx also if we choose sin x as the substitution. So remember this, you have to replace dx as well by dt. So if we choose sin x as t and proceed, what is the final answer? Please tell me. Just solve this
log
and then
mod of sin x plus c.
bye. You have to also find them. Then solve this first part.
Sorry, secret or cos x?
Sorry, what did you say?
Which part basically? The secret?
First part, cortex. First
Oh.
solve first part, then we'll proceed.
So the first one is log of sin x plus c.
Plus, correct. So we'll also put mod here because the input of log has to be positive. Be that easily on sec x and cosec x because they are not direct substitution. Sometimes what we have to do is we also have to think like, can I make it to the point where we can substitute, where we can use an ideal substitution so that the question is solved. Sorry, my bad. Sec x into dx. Okay, so what we are going to do is we are going to multiply and divide this sec x with sec x plus 10x. We have multiplied the whole expression and divided the expression by sec x plus 10x. Now, why did we do this? Can you tell me what is the differentiation of sec x?
Tan x dx.
Sec x and tan x, yeah. And what is the differentiation of tan x?
Sec square x.
Sec square x. Now see the numerator part. What is in the numerator? This is sec square x. If you multiply sec x with the whole, this would become sec square x plus sec x tan x, right? Which is what? The differentiation of this sec x plus tan x. So if you substitute sec x plus tan x as t now, it would become sec x, the differentiation of sec x is differentiating with respect to x on both sides. This would become sec x tan x, which is the differentiation of sec x, plus the differentiation of tan x is sec square x into dx is equals to dt. So this would become as dt by t, which is nothing but log of t. So I'm writing directly log of sec x plus tan x plus c. So the integration of sec x dx is nothing but log of sec x plus tan x plus c, which also means that if you differentiate this function log of sec x plus tan x, you will get sec x. Because the integration of sec x is this, so the differentiation of this is back to this sec x. Now, can you think how can I make this function integrable? I don't know the integration of cosec x. I don't have any substitution also. I mean, if I write it like this, then also there is no place of substitution for now. But can I multiply and divide it by something so that it becomes integrable? That I can substitute something just like I did in sec x?
Yes, sir.
What?
Cosec x minus cot x.
Cosec x minus cot x. Okay, try to solve this. What is the differentiation of cosec x? Minus cosec x cot x. And what is the differentiation of cot x?
Minus cosec square x.
Minus cosec square x. So, it's okay, try to solve. Nasir, do you understand Hindi?
Yes, sir.
So the problem is when you multiply with cosec x minus cot x, you would get the answer. But you will have to simplify the logarithm part also. And also think it like this, that differentiation of cos x is also negative and differentiation of cot x is also negative. So I won't advise you to multiply this with cosec x minus cot x when one is positive and one is negative. Either take both negative or take both positive. So I would say multiply this with cosec x plus cot x. That would be better. I mean, that would be less calculative. Now, if you take cosec x plus cot x as t, it will become minus of cosec x cot x minus of cosec square x into dx is equals to dt. You can take this negative common. This would become the same expression as above. So you can do this as minus of dt divided by t, which is nothing but minus log t. Minus log t is log 1 upon t. This would become log of 1 upon cosec x plus cot x.
Sir, I got a log cosec x minus cot x. Is that correct?
Yeah, that is also correct. Actually, that is the better substitution. I'm sorry. That is a better solution. Better substitution. Now, so next problem is, yeah. तो ये बहुत ही अच्छा हुआ that you did it by cosec x minus cot x, because that will also teach you something new. Liana, did you get it?
Yes, sir.
No? It's done?
Yeah, done, sir.
Okay. There's a problem. Okay. What is the problem? That Nasir ne solve kiya, so he got log of cosec x minus cot x. Now I got log of 1 upon cosec x plus cot x. I'm writing both. So one has already written. Nasir got this. I got this. This is a question to both of you. Can a function have two integration? Answer me this. Whatever is your answer. Don't think गलत होगा सही होगा. ठीक है जो भी होगा. क्या होना चाहिए एक फंक्शन के दो इंटीग्रेशन के एक्सप्रेशंस? Is that possible that a function can have two possible integration?
Yes, sir.
Is that possible? Nasir, you're saying.
Yeah, it is.
And why do you think so? Like, why do you think that this is possible? Like, is there a theory or you are just assuming?
No, like we got two answers, right? So I told.
Okay. See, we didn't have two differentiations for any function. So Nasir, basically differentiation and integration are two reverse processes of each other, right? If you know differentiation, you'll be knowing the basics of integration as well. So what happened in differentiation is that there were no function who has two differentiation. So it is certain that a function will not have two integration. But we are getting to, right? That is the problem. No, we have solution for this problem, but I'm just trying to realize you the problem. The पहला problem ये है कि एक किसी expression का दो आंसर नहीं आएगा, दो इंटीग्रेशन के पॉसिबल आंसर्स नहीं हो सकते, एक ही आंसर होना चाहिए. बट क्योंकि मेरे को यहाँ पे दिखाई दे रहा है दो अलग अलग आंसर, so I can say that these two answers should be same. So this will happen a lot. This is a very common problem faced by students when they solve questions from integration. They get answer other than that given in the answer sheet or your book. But don't worry, okay?
So,
Yeah.
to get log of cosec x minus cot x, what is the substitution used?
Which one? Log of cosec x minus cot?
Yeah.
So we multiplied this whole expression by cosec x minus cot x and divided by the same expression as well. So if in place of cosec x plus cot x, if I would have used cosec x minus cot x, the answer would be this, log of cosec x minus cot x. In that case, we have to substitute cosec x minus cot x, and then we have to solve. That is also correct. Yeah, no problem. But this is also correct. Both are correct. The only problem is sometimes we will get answers which are not given in the answer sheet. So what we have to do is we have to convert this expression, this second expression, into the first one. ये दोनों सेम ही है आंसर, बस हमें अभी दिखाई नहीं दे रहा है. तो अगर ऐसा होता है कि आपका आंसर कुछ अलग आता है from the answer given in the answer sheet, then what you can do is you have to convert this into this. Now, how you can convert this? You can multiply this expression by cosec x minus cot x in the numerator as well as denominator. So if you multiply in the numerator, this will become cosec x minus cot x. And if you multiply this cosec x minus cot x in the denominator, the formula will apply a plus b into a minus b, which would become cos x square x minus cot square x. Do you know what is cos x square x minus cot square x? Why? So the final answer is cosec x minus cot x only. They both are same. Don't worry about this. Just try to solve your question with the proper steps. If you get something, if you get answer something else than the answer sheet, don't worry. You may be correct.
We can do the same with integration of sec x dx, right? Okay.
Yeah, yes. Very cool. You can use this in that part as well. Okay, so now let's start with some questions on substitutions, good substitutions. Also, we have a lot of questions related to trigonometry in this exercise, 7.2. 7.2 or 7.3, I don't know. Yeah, 7.2. I have to solve those questions as well. So let's start with some questions. What I will be interested in is, I want to know what is the right substitution for every question. Okay. So sometimes I'll ask you orally, like, just tell me what is the right substitution and how can you solve this? Did you get it or not? And sometimes I'll give you the whole question. Like, you have to solve the whole question. So the first part, 2x upon 1 plus x square. Do you have NCRT? Both of you? Diana and Nasir, do you have NCRT right now?
No, sir, I would have to download it online.
Oh, it's okay. I can write a question. Yeah, no worries. And what about Nasir? Oh, Nasir. Now
I
you are
have, sir.
NCRT. It's okay. Because I'll have to anyway write it. Can I remove this?
Oh, yes, sir.
Okay, the first part is 2x by 1 plus x square. Nasir, first you tell me, did you get this? How can we solve this?
Yes, sir.
Now tell me, what is the correct substitution? I just want to know the substitution this time. Nasir, don't solve the whole question. Just tell me the right substitution. Whenever you find it, no worries.
X square.
Take your time. Only x square?
1 plus x square. No.
No, plus x square is okay, but yeah, that is correct. We can choose x square as t, and then we have 2x into dx as dt. So that is correct. But tell me, if I choose 1 plus x square as t, then what's the problem? It would be better to take 1 plus x square as t, because that will further simplify the expression, right?
Yes, sir.
Okay. So if you take 1 plus x square as t, this would become 2x dx is equals to dt. And this expression becomes dt divided by t, which is log t. Log t is log 1 plus x square plus now, second part. Liana, you have to answer this, but both of you solve the question.
So one minute, I'm working it out.
Yeah, no worries. Take your time. As soon as you get the substitution, just discuss it with me, then solve the whole question. Because if your substitution is not correct, then you are not going to get the answer.
Sir, we can take US TS log x.
Yeah, correct. But you don't have to answer this thing, Nasir. Whenever I'll ask you, then you have to answer.
Sorry, sir.
It's okay. I'm happy that you answered it.
So the final answer would be log x to raised to the power 3 divided by 3.
Log x to the whole power 3 divided by 3. Yeah, correct. Solve the next one. Nasir, you have already solved this whole exercise?
No, sir.
Okay. So which questions you have solved? How many questions you have solved?
No, I didn't start this exercise. Like today, he taught in
Okay.
school. So
Okay. Then so very good. You have to solve this. So what I'll be doing, Nasir, is I'll solve. You'll have to solve a lot of questions in my class. Okay. It's not like
okay.
you just have to study theory. The theoretical part is good, but see in the examination you'll only be asked questions, not what have you been taught in theory. So I'll be solving a lot of questions with you guys, and then you'll have to solve the question. Like 5 to 10 questions. There will be 15 questions. Like I set a target of 15 questions. I'll be around them only in the classes. Sometimes I'll solve 10, sometimes I'll solve 20, but I'll try to maintain an average of 15 questions per class. These are the easy ones, so we can solve 15 questions. And in the next class, Nasir, whenever you will come with doubts. I'll give you some exercise, I'll give you some questions. You come with doubts and don't hesitate. If you have doubts, if you couldn't solve any question, then it's okay. But you have to ask. Whatever you have problems, whatever you are facing problems, you have to ask.
Okay, sir.
Yes, so the third part. Third part is a good one. Not very good, but yeah, good one. No, it's
So
not
can you
given
write the
directly.
question? I don't have
Yeah,
it.
oh, sorry. Oh, yeah, no, my bad. I'm sorry. So this is integration of dx upon x plus x log x. These are not in proper order. Like the fifth question is not the fifth one in your book. Just giving you some questions. I have to solve these questions in today's class.
You find the right substitution for third question. Okay, so first of all, take x form. It would become x into 1 plus log x. Now think, what can we substitute so that its differentiation is also present in the same function? we have 1 upon x. Can you tell me what is the what function has differentiation as 1 by x?
1 plus log x.
Sorry, you're not audible. I mean, you was a once. Speak, Liana. And I was saying something. Now you can speak. Yeah, correct. 1 plus log x. Take 1 plus log x as t. Then 1 dx by x would become dt. So you'll be getting this. So these are easier examples. So you'll be getting them easily. No worry. If you put 1 plus log x as t, this would become 1 by x into dx as dt. Hence, we can write this as dt by t, which is nothing but log of t. Log of t is log of 1 plus 1 plus plus. Now this part. Sine of x into sine of cos x. Anji, fourth one. What do we need to substitute here?
Cos x.
Yeah, cos x. Correct. So if you put cos x as t, you get minus sin x dx as dt, which means that sin x dx would become minus dt. So this would be, I'm writing it directly, minus sine of t into dt. Did you guys reach it?
Yes, sir.
Liana?
Yes, sir.
Okay, so this would become sin t is minus cos t, and this would become plus cos t. Cos t is cos of cos x plus And if you're facing any problem, just don't hesitate, okay? You can ask me.
Yeah, so the next question I'm not sure.
Sorry, I didn't get you.
The next one.
Next one. Okay. So is that a question of substitution? Can we solve this or not? Substitution comes in the picture when we don't know the, I mean, when we can't integrate the given function. Because see, यहाँ पे हमें log x का whole square upon x लिखा हुआ था, हमें नहीं आता था, इसलिए हम substitution पे सोचना स्टार्ट किए. बट जैसे ही मैं इस क्वेश्चन को देखूंगा, क्या मुझे पहली बारी में ये लगा देख के कि हाँ मुझे नहीं आता रूट ओवर ax plus b? I think we can solve this directly, Liam. No? Okay. First answer this. What is the integration of root x dx? How would we integrate this? First solve this, after that, then we'll solve fifth question. Nasir, how would we solve root x?
We can write it as x raised to 1 by 2 dx.
Yeah, correct. Write this as x to the power 1 by 2 into dx. Then we can apply the rule of power, x to the power 3 by 2 divided by 3 by 2. Am I correct?
Yeah, so then here also will be the same.
So if we can solve this, so Liana, we can also solve this, because this is nothing but the linear transformation of x into ax plus b.
Then it will be ax plus b raised to 3 by 2 divided by 3 by 2 into a plus c.
Yeah, correct. We just have to divide the whole integration by a, the coefficient of x. Nasir, do you know this?
No, sir, I have some doubt in this.
It's okay, I'll tell you. See, you know the integration of root x, right? Did you get this?
Yes, sir.
Okay. So whenever we change x with some linear transformation, so what my point is, if I can solve root x, then I can also solve any function, any linear function of x. So let's say I want to integrate this x plus 2, root over x plus 2 dx. Yes, sorry. Let's integrate this root of 3x plus 2. So whenever this x is changed with another linear function, which is 3x plus 2, you have to do nothing. You have to apply the same rules which you were applying. So you will solve this like 3x plus 2 to the whole power 3 by 2 divided by 3 by 2. You just have to divide this whole integration with the coefficient of x, which is 3. So while transforming x into some linear function, you have to remember this, that the approach is same, but the final answer has to be divided by the coefficient of x. So if I divide cos over x plus 1, so if I divide, if I integrate root over ax plus b into dx, so first I'll check whether the function is linear or not. Yes, the function is linear. So what I will do is, this will become ax plus b to the whole power 3 by 2 divided by 3 by 2. We just have to divide this whole expression by a, which is the coefficient of x. Did you get it now?
Yes, sir.
So what would be the integration? Oh, sorry, just 1 minute. Let's say you know the integration of sin x, right? What is the integration of sin x? Can you tell me?
Minus cos x.
Minus cos x, right? So if you know this, you also know all the expressions which has x, which has any linear transformation with respect to x. So for example, you want to solve sine of 2x plus 3 into dx. So the answer would be same, minus of cos 2x plus 3. You just have to divide this whole expression by 2 because you have linearly transformed x with 2x plus 3. Okay. Now solve this one. Fifth part. Yes. What do we need to substitute here? Okay, substitute this x square plus x plus 1.
2x plus 1 dt by dx.
Yeah. It would become dt by dx would become 2x plus 1. So do we have 2x plus 1, Nasir?
No,
Not
sir,
yet.
but we have 4x plus 2.
Can we take 2 common from 4x plus 1?
Yes, sir.
Then it would become 2x plus 1. Am I correct? Write this as twice of 2x plus 1 root over x square plus x plus 1 into dx. Now let this x square plus x plus 1 as t. So become 2x plus 1 into dx is equals to dt. Easy. Whenever you are substituting anything inside a square root, you can also take this as t square, so that root over t square becomes t. The question will be much easier for you. Okay, solve this. Take this substitution this time. So this will become 2x plus 1 into dx is equals to this t square is 2t, and then differentiation of t is dt. dt by dx. dx I have already taken from this side. So this will become 2 into 2x plus 1 dx is dt, sorry, 2t dt. And this x square plus x plus 1 is under root over t square. This is 4 times t square dt, which would become 4 by 3 t cube plus c, which will be 4 by 3. And then t was root over x square plus x plus 1. This was t square. Remember this. So 4 by 3 t cube is root over x square plus x plus 1. This was t to the whole cube. You can remove this root and take the power as 3 by 2 plus c. Liana, did you understand this? Take your time and ask me if you have any doubt. Liana, did you understand this?
So when you have a constant outside and there will be final outside, example 1 by 3 into x squared plus the whole expression.
Actually, your voice is breaking. Your voice is breaking. Can you write whatever you were saying on chat? Please text me. No. 4 by 3 was out of the bracket. So 4 by 3 was in multiplication with t cube. Now for this, I've just substituted the part t, nothing else. Okay. So 4 by 3 was outside the bracket. It was always outside the bracket because it was with t cube. Okay. So I have just substituted the value of t back into the question, back into the answer. And that is why I got this x square plus x plus 1 to the whole power 3 by 2. 4 by 3 was already always outside this. Yeah, sure. Now solve these two questions. These are good ones. Dx by x minus root x. What should be the right substitution? You just have to tell me the substitution.
Root x minus 1.
Root x minus 1. Good. Nasir, and how did we reach to that part? Like how did we do?
Sir, you can take root x as common.
Correct. As soon as we take root x as common, this would become root x minus 1. Now root x minus 1, substitute root x minus 1 as t. Always remember this, okay? That the differentiation of root x is 1 by 2 root x. So if you take root x minus 1 as t, 1 by 2 root x dx would become dt. So 2 multiplied, take 2 on the right hand side. So it will become, the integration will become dt by, 2dt by t, which is nothing but 2 log t, which is 2 log root x minus 1 plus c. So the correct substitution was root x minus 1. And how did we get that? We have to take root x common first. Then we'll reach to the part where we start understanding how the substitution is done. Yeah, now feel free to ask if you have any problem. Okay. Okay, the 8th part you have to solve this by yourself. I'll ask you in next class. Also, you have to solve this complete exercise 7.2. You'll be facing a lot of problems. I'm telling you beforehand. You'll be facing problems. I mean, there will be questions which won't be solved. But you have to think about them. You have to think on them and then come with your doubts. Okay, in the next class.